Welcome to the Professional Machine Learning Engineer Crash Exam course. Today we will focus on a Model Context Protocol, aka MCP, and Universal Adapter for AI applications. It connects AI models and agents on one side to tools and data sources on the other, using a protocol built on JSON RPC 2.0. The philosophy is to build once and integrate everywhere. We are moving from static brains, like large language models, to active AI agents. LLMs primarily generate text and images. Active AI agents, however, can interact with third-party APIs, retrieve data, and execute tasks using tools and reasoning loops. Custom integrations lead to the MXN problem, where M models must connect to N tools, resulting in massive duplication. This creates brittle, unstandardized connections, requiring custom parsing and glue code for every system. The MCP standard standardizes the AI-to-tool handshake. For developers, this means zero custom integration glue code. For AI agents, it provides instant access to a massive ecosystem of external capabilities. End users benefit from personalized assistance that can take real action. The MCP architecture enforces a separation of concerns. The client, or host, handles intelligence and generative AI. The server, or host environment, manages data, tools, and business logic. The key rule is, clients request and servers execute. Server capabilities are defined by three primitives: tools for external actions, resources for data sources, and prompts for workflows. Tools are model-controlled, resources are application-controlled, and prompts are user-controlled. The transport layer matrix details connection methods. The modern standard is streamable HTTP, which supports resumability. Legacy standards include SSE and the local subprocess option, STDIN, STDOUT. A standard request follows a five-step lifecycle. It starts with initialization by the client and a capability response from the server. Once the initialized notification is sent, the execution phase begins, followed by termination to handle graceful closes. Advanced interactive workflows involve three circuits. Notifications allow async real-time messages. Sampling or reverse delegation lets the server delegate generative tasks back to the client's LLM. Elicitation, or human-in-the-loop, pauses the flow for user input. Server implementation can use a high-level API for simple servers via SDK decorators and automatic routing. The low-level API is required for complex features like sampling and elicitation. Context managers allocate and clean up server resources, and client configuration is managed via MCP JSON. Production security supports basic auth, JWT for granular role-based access control, and OAuth 2.1 for robust decoupling. Observability requires implementing distributed tracing, token budgeting metrics, and structured logging to monitor AI behavior. Resilience mechanisms include load balancing and rate limiting to distribute traffic, and circuit breakers to prevent token abuse or fail gracefully. Testing guardrails require CI/CD pipelines to run adversarial AI for detecting prompt injections and hallucination regressions. The agent-to-agent model solves the problem of bloated monolithic agents. Specialized agents, like the flight and hotel agents shown here, use standard MCP protocols to dynamically discover and collaborate on tasks without centralized hard coding.